Hello, I'm Xian Lee, and we're going to be explaining the Lab 8, the VCO, and the Schmidt trigger circuit. So basically, our part A consists of the IV curve of the amp. The part A considers this part, which is our current source, the voltage controlled current source. And so basically this potentiometer is here, and we use this op amp, and basically we can control the resistance of the potentiometer to change the voltage input. And we for our VCO we want a 10 volts, so that's where we adjusted this potentiometer to be at to allow the entire input to be at 10 volts, which allows a fixed current to come out of the E part of the transistor. And so basically our IV curve over here looks like this, where we so we had different measured different resistance values, the voltage and the output current. And so basically you can see that it has an inverse linear current. Basically at a very low voltage we have a high current, and as the voltage gets higher the current gets lower. It's very simple. And for our part B, which is a Schmidt trigger right here, we have the it's basically the Vref comes out here towards the 5 volts input, and we have the op amp. We're using LM348. It's the same one we used for the voltage current source. And basically the Schmidt trigger is just supposed to what it does is it changes the analog waveforms into a DC waveform. It changes from AC to DC, and it's a trigger. So basically, when you're given sufficient input, it flips. It needs to have the high enough of an input to flip, and so it's useful for removing noise. And finally, our V0, the VCO, is the final circuit. It's basically the entire thing, added with a couple transistors in the middle to make sure with the capacitor that it outputs a sawtooth waveform at VA, and which is more of a triangular waveform. And so this is what the output graph looks like. You can see that it swaps from the V rail positive to V rail negative at around the 7 and 3 volts, which is where our values are supposed to be. Thank you.